archaeologists use carbon dating to look at ancient human artifacts. And so it turns out that for the most part, it's got like usually it gives a really plus or minus 50 years date. Sometimes it gives the year, within 10-year time frame, sometimes, but this, and it does it correctly. So radiocarbon works for samples that come from, let's say, the last 2,000 years or so, maybe even 2,500 years. But once you get to, well, it's a famous study done by Manfred Bietak. He's a secular Austrian archaeologist, and he's been studying this region of Egypt called Avaris, and it's where the Israelites were encamped and where they lived during their sojourn in Egypt. And he's basically discovered that. He wasn't trying to, but he was just studying Avaris, and he was like, look at all these Hebrew-looking things. And then he dated 200 artifacts from that, from all over from artifacts from Avaris. And it turns out that the radiocarbon dates are systematically 100 years off of the calendar ages, or their calendar ages, right, for the chronology that they've developed. And so there's one group of archaeologists who are saying all the radiocarbon dates are systematically getting older, 100 years older at that age, and at artifacts even older from even times before have an even greater error margin. But other archaeologists saying, no, the radiocarbon dates are fact, and so you have to go redo all your chronologies. So there's this constant debate within the chronologists' papers and the archaeologists who try to reconstruct history. So anyway, all that to say, it's reliable until you get to about the time of the Exodus, which is like 1446 BC, according to the Bible's chronology. So once you get back that far, the radiocarbon dating seems to veer. So the radiocarbon ages look systematically older than the calendar ages, and we think we have a clue as to why that is. And that's kind of the side of the debate that I land on, is that the radiocarbon dating has got problems. Now, how do we know that it does work for artifacts that are only a couple thousand years old? Well, they're from archaeological contexts that have timestamps in the same layer. And so you have pottery made during a certain era in a certain place. So pottery is characteristic of a culture and of a time when that culture lived. Or even a coin with a Roman, or an Egyptian, like a bulla, which is an Egyptian seal which has a particular pharaoh on it. So that helps to limit your time frame when that could have been deposited. So when you have someone's name, like a pharaoh's name or a Roman emperor's name on a coin or something like that, and you carbon date something from the same layer, you have a nice independent cross check of that carbon date. And it turns out that the carbon years in those cases very often, not always, but they often match the actual calendar years that we have attached to those layers.
And they're not looking at the calendar year first and then sending that calendar year to the lab saying carbon date this, here's what we're expecting. Or I mean, is there any bias that can be going into making sure those are accurate? Or no, those are just pure scientific numbers. This is what we come back with based on a half-life of 5,730 years.
I'm sure that there's small bits of bias, but it's hard to argue against a suite of multiple independent chronological markers like that. So if you have radiocarbon years that match the calendar years that from some other time indicator, like something written like a king's name during that king's reign, well, and then you can cross-check the king's reign time with historical records where people wrote it down. Now that's really the best history. If you can go back to written records, just like in the court of law, that's how you reconstruct the past, is by going to what people wrote down, people who lived there at that time, and to reliable records of reliable eyewitnesses and historical witnesses. That's that's really very solid. So it's not, it's, if you, when you say, Eric, you say pure science, it's like, well, these are all historical sciences. We're talking about forensic analyses, basically. And so we're not talking about the same kind of science where you repeat an experiment and anyone can repeat it and observe it, and you're watching the process happen through time in your lifetime. Like right now, you can repeat it again. That's like empirical science. That's the kind of science that develops technology, put the man on the moon, gives us cell phones, all that kind of stuff. But forensic science is reconstructing the past. And so you do different procedures, and you cannot know with as much certainty with just processes, because you have to make inferences. Has this process been going on at the same rate in the past? Did something else affect this process in the past that we're, that we can't see anymore, because that whatever affected it is now done, is now gone. Like Noah's flood could have affected, isotope ratios and things like that, for sure, etc. But when you have people wrote it down in the past, boy, that's the way to go when it comes to history. And what you and I have landed on, I think, over the years, is coming to realize, wait a minute, the Bible itself is a reliable witness of history, written down by reliable eyewitnesses. These things really happen.
They did indeed, and that's what we base our entire trust on, is revelation from God and the resurrection of Jesus Christ. I love it. It really did happen. That's to me, and I'm sorry, I'm getting on my preaching thing. I keep going, when I meet Christians that question whether it's true, I'm like, well, then do you also question whether, how you should behave? Or maybe that's why we got so many problems in the church today, because people aren't behaving like real Christians. And maybe it's because they're like wondering, I wonder if it's all really true. And it's true.